Hi friends, today we dive into the amazing laws of thermodynamics. Let us first discuss the zeroth law of thermodynamics. First of all, the statement: if two systems are in thermal equilibrium with a third system, they are in thermal equilibrium with each other. Explanation point by point. System meaning: a system means any object or body we are studying. Example given: cup of tea, thermometer, block of metal. We label them as the system A, B, and C. Thermal equilibrium means same temperature. Two systems are in thermal equilibrium if there is no net heat flow between them. This happens when they are at the same temperature. The third system means reference. Imagine system A and system B are not directly compared, but both are separately compared with a third system, system C, like a thermometer. This condition given in the law: if system A is in thermal equilibrium with system C and system B is in thermal equilibrium with system C. Logical conclusion: then system A and system B must also be in thermal equilibrium with each other. Meaning, A and B have the same temperature since both match with C. This law establishes the concept of temperature as a measurable, comparable property. Without this principle, we could not use thermometers. Suppose you put a thermometer in hot water. After some time, both show the same temperature. Now, put the same thermometer in a glass of milk. It also shows the same temperature as before. From the zeroth law, hot water and milk are at the same temperature, means thermal equilibrium, even though they were not directly compared. In short, the zeroth law is the basis of temperature measurement and thermometers. Next, we discuss the applications of zeroth law of thermodynamics. First one, basis of thermometers. It means thermometers work on the principle of zeroth law. If a thermometer is in thermal equilibrium with a body, then the temperature of the thermometer is equal to the temperature of that body. This allows us to measure temperature accurately. Second one, used in temperature scales. It means the zeroth law provides a foundation to define temperature scales like Celsius, Fahrenheit, and Kelvin. Because of this law, temperature becomes a measurable physical quantity. Third one, heat exchanges. It means in devices like condensers, boilers, and radiators, heat transfer takes place until thermal equilibrium is achieved. In simple words, zeroth law makes temperature measurement possible, helps in creating temperature scales, and explains heat transfer balance in practical devices. This image illustrates the zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. In this diagram, if body A is in thermal equilibrium with body B, indicated by the double-headed arrow between A and B, and if body B is in thermal equilibrium with body C, indicated by the double-headed arrow between B and C, then body A is also in thermal equilibrium with body C, indicated by the double-headed arrow between A and C. This law is fundamental to the concept of temperature and its measurement, as it allows for the use of a thermometer, means the third body, to compare the temperatures of other bodies. Next, we will discuss the first law of thermodynamics. Statement: energy can neither be created nor destroyed. It can only change from one form to another. This means the total energy of the universe is constant. You cannot make energy from nothing. You also cannot make energy vanish completely. The total amount of energy always remains the same, conserved. Explanation with simple examples. First one, electric bulb. Electrical energy converts the light energy plus heat energy. Energy is not lost. It just changes its form. Second one, food we eat. Chemical energy in food that converts to the mechanical energy means muscle work plus heat energy body worn. Third one, hydroelectric dam. Potential energy of stored water converts to the kinetic energy of flowing water that converts to the mechanical energy means turbine. Again that converts to the electrical energy. In simple point, energy transforms from one type to another, but the total energy before and after remains constant. Mathematical form: delta U equals to Q minus W, where delta U that equals to change in internal energy of the system. Internal energy means the total microscopic energy inside the system means kinetic plus potential energy of particles. Q that equals to heat supplied to the system. If heat is given to the system, energy increases. If heat is taken away means energy decreases. W means work done by the system. If the system does work on surroundings like expansion means energy of system decreases. If work is done on the system means energy increases. Meaning of the equation: if you add heat Q to a system, some part of it increases the system's internal energy delta U, and the rest is used for during work W. So, energy is just redistributed between heat, work, and internal storage. Example: boiling water in a closed vessel. Heat Q is supplied from the stove. Part of it increases water temperature means delta U. Rest of it may cause expansion of steam means W. Next, applications of the first law of thermodynamics. Heat engines means steam engines and IC engines. In an engine, fuel burns and releases heat energy Q. A part of this energy increases the internal energy of gases inside the cylinder. Another part is used to do mechanical work by moving the piston or turbine. Not all heat is converted into work. Some heat is wasted. Examples: car engine, steam power plants. Second one, refrigerators and air conditioners. In refrigerators, external work is done by the compressor. This work helps transfer heat from the cold body to the hot body. According to the first law, energy is conserved, but external work is necessary for reverse heat flow. Example: domestic refrigerators and air conditioners. Third one, human body means metabolism. Food contains chemical energy. In digestion, the chemical energy is converted into internal energy and work like walking, breathing, muscle movement. It is also released to maintain body temperature. Example: running and exercise. Fourth one, boilers and calorimetry. In a boiler, heat is supplied to water. Part of this heat increases internal energy of water. Means temperature rise, steam formation. Remaining part is used for work of expansion of steam. Example: steam power plants. Fifth one, electrical systems. In an electric heater, electrical energy is completely converted into heat energy. In motors, electrical energy is converted into mechanical work means W. In bulbs, electrical energy converts the light plus heat. Examples: heater, fan, electrical bulb. Sixth one, rocket propulsion. It means chemical energy of fuel converted into heat. Hot gases expand. Converts the do work means W by pushing rocket upward. Some energy also increases internal energy of gases. Example: space rockets and missiles. The image illustrates the first law of thermodynamics, which is a statement of the conservation of energy. It states that the change in the internal energy of a system delta E or E2 minus E1 is equal to the heat added to the system Q minus the work done by the system means W. Explanation. State 1 represents the initial state of the system with a certain internal energy means E1. Heat transfer Q represents heat is transferred into the system increasing its energy. Work W represents the system performs work, which in this case is shown by the upward movement of the piston, indicating expansion and work done by the system. Step 2 represents the final state of the system with a new internal energy E2 after heat transfer and work interaction. The relationship is expressed by the equation E2 minus E1 that equals to Q minus W, where E represents the internal energy.